So it's all good. Yeah, I guess a little bit of just morning housekeeping. So with the exam, it looks like Gordon's going to be primarily responsible for creating the exam for you guys, and he's probably going to have it sort of programming centric. I'm going to speak with him and saying, yeah, I'm going to speak with him about the theory component of it, but it's a lot more feasible because it's an open book sort of situation. That it's just going to be sort of a practical kind of open book. Here's a develop a script to do this, or develop a piece of code that does that, and then that will be it, right? So
Yeah, I recognize previous years have had like pretty much entirely practical based uh, exams. There was really a theory component to it, but
yeah, that's fine.
yeah,
I'm totally okay with it. I feel a little bit left out, but it's all good.
yeah,
you know,
yeah.
um, yeah, for me again, I think part of what my component to this module is to give you guys a little bit more context of what you are designing. And I think I've mentioned in the past, I'm a little bit religious about that because in the productions that I have been in, there's a huge disconnect between the software engineers and the technical art team. And so I have an opportunity to go, well, I'm going to introduce you guys to what the technical art team does, and then that way you have a clearer kind of picture and understanding of what that relationship is. So that's sort of my ethos. um let's see what else was there. Oh yeah, so we're a little bit on the back foot. We've only got a couple of weeks left, right? And I know you guys were interested in further Unreal kind of lectures, which I'm planning on giving. But I wanted to spend the majority of today talking about texturing because I think it's a potentially complex thing to wrap your head around, and I just wanted to spend a little bit of time on that. Now, having said that, I don't mind resurrecting our 1 to 3 time slot that we normally have on the Mondays. Not just simply for a one-off makeup session, but for the next 2 3 weeks, right before Easter holiday. I don't mind. And then that way you get sort of like an extra 2 hours of Unreal tuition, sort of for free. And for me, I'm really comfortable with it because I feel like you guys were sort of left with a bit of a raw deal when Andy left, and we scrambled to get myself in place, and then I scrambled to get Dave and John in place. So sort of as compensation, you'll get a little bit of extra Unreal tuition. How does that sound?
I
Anybody?
think yeah, no, it's helpful to have extra time
Yeah,
back because a lot of the
yeah,
time the university doesn't redeliver on that.
yeah. No, I'm really kind of flexible, in that regard. So I don't mind spending additional time with you guys. Uh, and this way, at least you guys get a rounded out experience, but at the same time, you don't feel like it's encroaching on actual coding time, which I understand. I completely get. A lot of you guys just want to put your head down and write code. So Dave and John are giving you an extra hour, right? Is that right?
The graphic support sessions on Wednesdays, yeah,
Yeah, that's
there is
right.
that extra hour, and
I
right
could.
now it's not really being used as lecture time though.
Okay, that's good. We'll sort of redefine that because again, one of the things that the conversations I had with Gordon was I basically said, look, these guys want to do more coding. I think I'm totally okay with having them take over this module. The problem with it is that they're not lecturers, so I have to be there in a supervision capacity. So that's kind of cool. But when I talked with Dave and John, they just said, well, we can only commit to an additional hour, which is totally fine. That makes it
Yeah,
comfortable for me because I can give you an hour's worth of theory, and then you're getting what 3 hours of coding with those guys, which is really really cool. I will talk to them about their. Would you rather have tuition? Because I think it's a good call that they're doing that extra hour as sort of a workshop and feeding back on your stuff. I think that's sort of an important part of the process. But would you rather have a lecture?
well, I mean, I think our current structure is pretty okay. Um, I think the extra hour is fine to be used as a general support hour because,
Yeah, yeah, yeah.
well, we
Yeah. Okay. Yeah. Sounds good. So we'll keep to this sort of structure, and then we'll make it over to Easter, and then I think you will get all the tuition that sort of Andy Baker meant to kind of give you guys before we took off, right? So I say take off. He didn't really take off. Make it sound like he jumped the country. Um, so yeah, so that will be the what it'll be like on balance. So yeah, with exam questions, I think it'd be a good idea to redirect to Gordon because he'll probably from here on out help you out with sort of what content to focus on and that kind of a thing. Okay, so having said that, I'll still be sort of streaming lectures. This one's being streamed today because I know that texture unwrapping and UV mapping is a little bit of a complex topic. So, all right, without further ado, I'll sort of dive into it. Now, one of the things that I generally tend to start off in terms of UV unwrapping is to describe the relationship between UV coordinates or texture coordinates and the surface geometry. One of the biggest problems that I think a lot of digital artists or people who work in computer graphics have to deal with is this notion that 3D space doesn't actually exist. It's a representation of 3D space on a 2D plane, right? Now, you know, that might seem fine and good in theory, but when it comes to texture mapping, people get sort of confused because what they're trying to visualize is, well, how do I get my 3D object painted with the photographic textures that I need? And that's where sort of this concept of UV unwrapping is quite confusing because everything that exists in terms of a 3D context is a planar projection, right? Everything's being projected via a 2D plane into sort of a simulated 3D space, right? So to simplify what I just said, the metaphor I generally tend to use, which I mentioned briefly last time, is try to imagine Christmas wrapping paper because that's the best way to contextualize what UV map is, right? So with Christmas wrapping paper, there's only one side with a pattern, and that's your side with the normal facing, that's your normal facing direction. But the ideal goal of wrapping a Christmas present is to do it in a manner that hides the seams, right? So oftentimes we'll try to, when we tape up the present, we'll tape it up on the bottom or the back of the box or what have you, just to make it look nice and neat. We also try to reduce the crinkles. It sounds incredibly pedantic, but this is exactly what we're doing when it comes to UV mapping and UV unwrapping, right? Let me just go in and grab my screen projection here. Project that screen. What we were essentially trying to do is we're trying to create a crinkle-free packaging on an object. Now, if we get something like a novel, that's not a problem, right? That's fairly easy to sort of kind of wrap your head around, right? So if I were to come inside Maya here, let's wait for Maya to do its preload. So when we're looking at, you know, wrapping up a novel or something like that, or, you know, our brother or sister or whatever, it's fairly simple, right? It's rectangular. There's one place that may have a seam on the back, right? But when it comes to something like a packaged action figure or a coffee cup, then it becomes a little bit more complicated, right? Now, remember, the goal of proper UV mapping is that planar projection can wrap around, let's say, action figure, because oftentimes you guys might be taking a look at textual coordinates on a character model, right? So if you look at wrapping an action figure, it becomes infinitely more complex to try and take that flat planar texture surface and map it in a way so that there's no overlapping crinkles and no seams on the action figure anywhere, right? I usually do a visual metaphor because it's essentially the same thing. So one of the things that generally ends up happening with UV unwrapping is that people will tend to they'll try to just sort of rush through and wrap everything with very, very small sort of pieces. And I'll show that to you. Actually, let's come in here and create a cube first and take a look at what we're dealing with. So I'm gonna pop in a cube, frame up on this, right? And I'll talk a little bit about the relationship between this and the texture space in terms of UV coordinates and texture mapping. So let me go to my model UV editor, bring this guy over here, and we'll talk a little bit about this. We're going to be covering not just planar mapping, but the various different default mapping types, and then we'll talk a little bit about sort of pelt mapping, dealing with UV shells, managing UV shells, talking about UDIMs as a new way of what do you call it? Sort of cataloging UV pages, texture pages, and then we'll talk about multi-texturing and multiple UVs, which starts to get really, really complicated. Okay, so I've got this cube here. There's a couple of things I'm going to do. I'm going to bring that back, but I'm going to dim it down, right? Okay, so basically, this makes a little bit more sense in terms of trying to understand this whole idea of wrapping a box, right? Because we've all seen unfolded cardboard boxes before, and they generally unfold like this. So basically, if I were to take this planar projection and project it directly onto the cube, we know that the texture coordinates will work because we've assigned various UV coordinates to it. So basically, we've cut out a piece of Christmas paper in this shape, right? So we know that when we slap it onto the cube and wrap it up, it'll look nice and neat. Obviously, we've got more edges than we would like, right? And those edges are generally defined by these thicker white lines. I'm just going to CF. So the thick white outline there indicates where we have our seam lines. So that would appear as cuts. Now, the idea is there are two things that we can do. We can either make a continuous seam across those areas, or we can ensure that the texture tiles in a way such that the pattern joins up and looks invisible to the audience, right? So those are some of the things to look out for. The difficulty I think that people generally tend to have with UV unwrapping, yes.
There's quite a lot of pixelation on the screen.
Is there?
Doing, yeah.
Right. Okay. So let's see. Is that on the Discord stream or on my Twitter
stream?
On the Discord stream. Let's see if we can correct this. So I might, you know what? I think I'm beaming the wrong thing at you guys. Let me try this again. Hang on. All right. So that's that. And that's screen to should be this guy. All right. Give it a second. How's that?
That's much better.
Okay, cool, perfect. Okay, so I think one of the difficulties, though, that a lot of people have is that the process of UV unwrapping is actually the opposite, right? Where instead of unfolding sort of a cardboard box to kind of get our UV coordinates, we're actually setting up our UV coordinates here so that it can fit on the box. I'll show you what I mean, right? So when we come in here and take a look at this box, and if I were to right click and grab these UVs, I can grab this guy there and there. So I can move those UV points around and you can see what's happening on the cube itself, right? Because again, these are texture coordinates that reference an area on the cube so that when I planar project the texture, it'll find its location on the 3D cube. Now, a lot of people sometimes get confused because the UV coordinates are located on the vertices, but they are not the vertex in terms of the data it carries, right? So one of the things that an artist will generally have to do is to unwrap an object, and I'll take you through that process. Right? So that's a planar projection. Let's take this object, move it off to the side. We will create a spherical object. Bring this guy in. And again, same sort of principle. This is a spherical map. And, you know, those of you who have owned a globe at some point in your life will understand a little bit about this concertina patterning up at the top. Because again, you've got this flat planar image that you're trying to wrap around the sphere, and up in the polar coordinates, there needs to be a way of folding that paper so everything dovetails nicely and creates a seamless image. But you guys can see that there are already a number of issues in terms of what's happening at the polar coordinates, right? Now, with a graphical print sort of medium that would be used in a globe, you don't have that much of an issue. But when it comes to projection, you know, the projection mathematics happening in the background, it's going to cause a lot of what are called visual artifacts. And these are the one things that a lot of texture artists have to pay attention to and keep an eye on, right? So what do you generally do in a situation like that? Well, this is a procedural UV unwrapping. What we would generally tend to do, we would go back in and we would do a manual UV mapping operation on this, right? So those of you have done some shader tests and things like that on spherical objects may have run into funny things up in the polar coordinates. It's in all likelihood because you're using the procedural UV unwrapping that that the parametric object came with, right? So let's go into, I'm only going to bring in one other object. They're all sort of same, they're all similar in context, but the cylinder is an excellent one to talk about simply because of some of the strategies when it comes to UV unwrapping or figuring out those texture coordinates. So if we take a look at this cylinder, you can see that it's actually been cut up into a couple of pieces, right? So we've got that sort of central UV space going through the body of the cylinder, and then what are called the UV caps, right? So we've capped up the top and the bottom with those. Now, we can see just by the default procedural operation that there are issues here, right? So this is really important to talk about because this is texture stretching. Now, I've talked to you guys a little bit about polar coordinates. Texture stretching is another huge issue that texture artists and shader developers run into all the time in terms of using photographic textures. So what is happening here is we are effectively, if you can imagine, sort of Christmas wrapping paper having some kind of elasticity to it, right? One sec, I'm just gonna grab this guy and then right click and go to, oh, and let's go to, oh, there it is. Okay, so if you can imagine that Christmas wrapping paper has some sort of elasticity to it, right? What we've effectively done is we've cut a fairly thin strip and then we've stretched it around that cylinder object, right? And what happens is image distortion and it looks awful, right? So what we need to do is we have to go in there and adjust our sort of UV sheet and say, look, we got to cut a larger piece because that projection is not accurate or one-to-one to the surface. So we're actually saying, look, instead of stretching that Christmas wrapping paper, let's make sure we cut the right size and project that on. So what's physically happening in the background is you're getting a small pixel density space being camera projected onto the surface of the object, and you get all kinds of stretching, right? So this would be a much more accurate way of UV unwrapping that particular cylinder. Now, we do have a problem, right? Unlike the other objects before, there's a definite cut in the patterning between the top and the bottom, right? There are two actually issues going on here, right? So we don't have a continuous tile over that seam. That's one thing. And the other thing that's happening here is that our texel ratio is off, right? And I'll talk a little bit more about that, right? You might get into a UV mapping situation and think, well, you know what? I'll just sort of shrink those UVs down and give myself more space on the texture page. But again, you're doing the same thing. Effectively, you're creating a tiny piece of Christmas wrapping paper and then trying to stretch it around your object. And what ends up happening is that you get a resolution mismatch between the end caps and the body of your object, right? And then you can see all kinds of aliasing, right? Hence why a lot of UV unwrapping utilities these days come with these square checkerboard patterns. These checkerboard patterns are there to ensure that you've got the correct texel ratios, right? And again, I'll talk about that, but a texel is simply a textured pixel, right? And what we are effectively doing as artists is trying to make sure that A, the squares look like squares, which they currently don't, right? So I'll stretch this out till they look like squares. And B, the squares look like reasonably the same size all over the object. What this translates to is when you apply your final textures, etc., onto your object, you won't have areas that look soft and then other areas that look sharp. And then it just looks like a patchwork quilt of various different levels of pixelation, right? So, and again, we are dealing with 3 planar projections, right? In terms of the UV shells we're projecting. So let's go back to the sphere and let's solve the issue of the polar coordinates, right? So I'm going to come over here. I'm going to grab this object, move it out of the way. And we'll zero this guy out. Let's pop back over to our attribute editor and we'll zero this guy out. Back up world 0, 0, 0. Okay, so if we have a situation like this, oftentimes as a texture artist, your strategy is how can we cut this sphere up with a minimal number of pieces where there's no obvious seam that we can reproject our texture, our planar texture onto this, right? So instead of that one sort of cylindrical texture with a concertina pattern, I'm going to try something a little bit different. So I'm going to pop over to my right view and I'm going to zoom in here and I'm going to go to my face selection mode. I'm going to select those faces there, right? And I'm going to pop back out to perspective view to check my selection, right? So I've selected basically what looks kind of like a dish, right? So I'm going to come back up into my modeling menu under UVs, and I'm going to reproject those coordinates into 2D space, right? So I've got a few different ways of approaching. I'll talk a little bit about the 3 default ways of mapping: cylindrical, spherical, and planar. I'm just going to hit it with a planar projection, right? So that's going to zap down. And I need to pick the correct orientation, right? And we'll talk a little bit about, rotate through the X. We'll talk a little bit about the different bits and pieces that are at work here. And we will come in here, and let's make sure that projection. There we go. So we'll just do a 1-in-1 projection. Right. Okay, so with that in place, I'm going to come over here and I'm going to open up the Windows Node Editor so we can talk about the different operations that are happening here in a way that it might sort of contextualize it a little bit better for you guys, right? Oh, there you go. Okay, so what I've effectively done is assigned a set of faces to a selection set and said, look, I'm just going to do a planar projection on that, right? So it's basically, I've cut out that piece of paper and just said, I'm going to stick it on like that, right? And we've gotten ourselves a new sort of shell and a new node, which I'll talk about. So I'm going to come over here. I'm just going to grab that shell, and I'm going to move it off to the side. There are a few different things happening here, right? So number one, we now have a planar projection node, right? So this is a separate calculation that deals with what I call a texture support. It's kind of like a coat hanger or a framework for that projection, right? And so this framework, you can control its center and its rotation, width, etc. But it's basically in charge of moving our sort of projection plane around so we can get that really, really good image. Now we've got a couple of things when we take a look at the texture coordinates here in the UV editor. Number one, the shell is colored red, and number two, it's huge, right? So when you are projecting onto a 3D object, one of the things to be very kind of wary of is the normal's direction. Now, most UV editors will tell you, okay, you know what? You've actually put that wrapping paper on the sphere upside down. So all I see is the white side, right? So this is the normal facing side, and it's incorrect, right? So I have to come in here, and you know, it could be as simple as, oh, actually, it's not going to let me scale through anymore. Let's see if we can. Oh, I know. So I'm going to go back to my face selection mode. I got these guys. And get on the right view. And I'm going to go to my display and there it is, mesh display, and I'm going to reverse those normals. There we go. So I've just selected those faces, and that just told Maya to reverse the normals and make sure the normals are pointing outward on the geometry. You can see that our shell coloring turns blue, and when we take a look at our mapping, right, we have an accurate mapping. Ah, no, what's going on now? I just undid this backwards, and I still get the same texture inconsistency. Then it becomes a case of, what do I trust? Do I trust the UV editor, or do I trust the viewport display? I'm just going to redo that, because ideally what should happen is, now that the normals are facing the correct way, we should be able to read U1V21011 there, but it's not displaying it for me. That's okay. The concept, anyway, is sound in the fact that we need to make sure all of our normals are facing the correct direction. We also need to come in here and make sure we've got this sized correctly so that our texel ratios fit, right? Now, the other thing that I will tend to do with a shape like this is I'll come to the other side and do the exact same thing. Ideally, you'd want to match your selection to what you had before, but it doesn't matter. You know what? I'll go slightly larger so that you can see some of the things some of the problems you may encounter if you go a bit too far, right? So actually, that's a good point. Let me grab a few more of these guys, and we'll go over here. And again, I'll come over to my UV menu set, and I will reproject another planar projection, right? So I'm going to go, this time I'm going to dictate, I want to go down the y-axis, fit to the bounding box, and I'm going to apply this. So that should give me a nice square projection, and it fits the bounding box nicely, so I didn't have to fiddle around with the projection, right? So same thing here. I'm going to come back, and I'm going to select the faces here, and I'm just going to reverse the normals on this. Now, there's a way of doing it inside the UV editor. I was doing it the old school way, which I guess no longer applies. But what we generally used to do back in the day is we'd simply grab our UV shell and then scale it through to the negative. But I've got a limit there. So that must be a new feature in 2020. So I'm going to scale this guy down, and we'll talk a little bit about what is happening if you go a little bit too far, right? Well, and it's a good thing to sort of observe, right? So if I come over here, and let's raise this up over the world grid. If I come here, you can see that from the top, we've got fairly decent representation of the grid lines, right? But as we get around the sides, here we've got texture stretching, right? And that's, again, something we're desperately trying to avoid. And again, this has to do with how the projections work, right? I think another metaphor that I generally tend to use is, well, I've stayed away from this because you guys are young enough, you may not have had this in school. But in school, we used to have lectures given sometimes with a projector or an overhead projector, right? So when you stand in front of the projector, the image will broadcast itself on the side of your face or whatever, but as the projection beam starts to hit glancing angles, those images will start to stretch across along the sides of your head, right? It's the same kind of thing because we have a projection beam that's looking to shoot straight through, right? And so effectively what we're getting, let me switch over to Photoshop to kind of better describe this. Let's get this. So if I come in here and do a god-awful mouse drawing, and we got a plane here, and say this is divided up with pixels, right? You know, we got a one-to-one relationship of the pixels to the 3D surface in terms of how it maps onto the 3D surface. But over here on the edge, we're asking 2 pixels to map across a surface that's quite long, right? And so that's what causes the stretching, is that relationship between the projection and the surface area we're projecting to and the angle that is receiving that projection data, right? So generally, we try to kind of balance out what we're projecting in terms of a planar projection with how the angles are working on that object, right? Okay, so how we would deal with the center is we would just simply do a cylindrical map. And a cylindrical map is just, here, I'll just show you actually. Let's do that instead. Come over here, I'll grab these faces, right? And even though it's already cylindrically projected, we'll come back over here and I'll do a cylindrical projection. The cylindrical projection is basically a planar projection that's already been sort of calculated to assume a cylindrical shape, right? And so you can see our gizmo has changed from a planar gizmo to something that's semicircular, right? To indicate that we've got that cylindrical projection, right? So I'm gonna bring this down to size, and I'm gonna come back in here and we'll grab these UVs, right? We'll move them into place, right? I'll talk a little bit about texture pages in just a second. So I'm just going to grab this guy, move him down here, right? Now, again, what we're trying to do is we're trying to create texture projections that work in a planar space. Now we've got, again, more issues. Because this is not a complete cylindrical surface, we have a little bit of belling happening, right? So we've got more or less the best square sizes round about here, but then it starts to squish up at the top and stretch towards the bottom, right? So again, this is sort of the bane of working with texture coordinates because again, ultimately we want everything to be even squares, evenly wrapped around the surface with hidden seams. So you can see it's sort of the difficulty in terms of managing this just on basic primitives, right? And once we get into a character, and I'm going to try to dig up an old character model of mine, we're going to dive in and we're going to take a look at some of the strategies in terms of dealing with that complexity. Now, I'm not going to go in and UV unwrap an entire character because you guys aren't artists, but I'm going to show you some of the problems that are encountered and some of the ways we sort of circumvent that, right? Now, I've already talked to you guys about the problems of having incorrect textual ratios. I've also talked to you about polar coordinates and inverse normal facing shells, right? There's another issue as well, and that is overlapping UVs, right? Because what ends up happening is, even though we're moving these guys around to try and get them into a particular space, and then we look at the 3D object and you're just like, oh yeah, it's fine, it's cool, it looks all right. What actually is happening is there's a conflicting set of data. Obviously, there's a conflicting set of data because we have a singular area on our texture map being shared by two surfaces, right? So that generally leads into rendering artifacts and problems a little bit later on down the line. So the general rule of thumb, although it's not going to cause your renderer to explode, it's not going to shut down your renderer, but the general rule of thumb is when you're setting up your projections, you want to make sure each individual group of faces has its own projection coordinate area, right? So even if it's at the cost of resolution. So if we were to say, grab these guys and say, you know what, that's the resolution that I want. That's the size of the squares that look really, really good when I ultimately replace it with the texture. You have to make the call and say, well, I want to avoid overlapping UVs, and I want to make sure that that sits nicely on the texture page. The texture page has UV coordinates from 0, 0 to 1, 1, right? So it's a set of normalized coordinates, right? This is the only grid that is referenced by an object, right? So notice how when I scale these guys up, other grids would appear. So you think, oh, okay, well, I've got all this space to work with. You don't, because what is happening in the UV editor in the background is that the 0 to 1 UV space is automatically being tiled ad infinitum in all directions, right? So you're actually repeating the texture over and over and over again. So generally, and especially with game artists as well, generally, you want to keep your UV unwrapped character or prop or what have you contained within this 0 to 1 UV texture coordinate space, right? So that's generally how that works. Now, some of the eagle-eyed amongst you may have noticed that as I scaled this up, actually, no, the UV coordinates have changed. That's a whole other technique, which I'll get into a little bit later, right? Because there are ways of using these various different areas using UV sets. And UV sets take those UV coordinates and, again, assign them within their own sort of set, and then you can assign a variety of different UV pages to those UV sets. So you can possibly maximize the use of this area out around here. But that's, again, a slightly more complicated way of approaching it. So I've mentioned texel ratios quite a bit. Let's pop in and talk about that and what that is, right? So as I do that, any questions so far about what I've talked about? No? Okay, that's cool. So I'm gonna pop this open. Now I'm using this image. One sec here. Photo. Let's see, maybe I can use. Just gonna use not PhotoPad. Oh, maybe this would be good. Okay, so I generally tend to use this image that I found years ago on ArtStation by an artist named Leonardo Ezzi. And the reason why I use this is because it's perfect. He's got this visual guide that's really, really good in terms of understanding texel density and texel ratios, right? So basically what a texel ratio is a relationship between the textured pixels on your image to the pixels on your screen. Does that make sense? So ideally, if you are broadcasting your stuff or rendering your stuff to 1920 by 1080, and your object is occupying the entire screen, you want the texture on that object to be 1920 by 1080. So you have a one-to-one relationship between the textured pixel and the screen pixel, right? So this is generally a problem that exists with a lot of default mapping techniques, or a junior artist who's not quite familiar with texel densities. Oftentimes you'll get a variety of different 3D objects mapped with various different sort of texture resolutions, right? So you might have like a 4096 by 4096 texture on this box. You might have a 512 by 512 on this box, et cetera, et cetera. 128 by 128 on the back wall here, right? So when you look at the grid pattern, it makes obvious sense that the texel ratios are off. They've got the wrong density. But what ends up happening as a cost is that if you were to replace your grid with the final textures, like a robotic texture or what have you, you would get a scene that looked awful. It would look really blurry, fuzzy, muddy, and strange. There'd be a strange sharpness to certain objects, et cetera, et cetera. So ideally, what you want to do is you want to get a situation where you have uniform density on all of your objects, right? So the way to kind of handle this is to be able to unwrap your objects in a manner that, well, I'll show you when we get into Maya, but you want to be able to unwrap your objects in a manner that the scale of the UV shell fits the scale of the object, right? So UV scaling is another huge issue in terms of affecting visual impact of objects, right? So if I were to come in here and say, yeah, let's do that. So I'm going to bring this object over here, and we'll just scale this guy down, and maybe make this guy super huge, right? So let's say we have a situation like this. I'm going to come through, and I'm just going to right-click, and I'm going to assign a new material just to blow away all the UV coordinates. We'll put I'll chuck a new Lambert on there, right? So they're all sharing the same material, right? And I'll also, let's do that. I'll also combine these objects. So I'm going to combine these objects so they're one single contiguous piece of geometry, right? So I can select on it. They're all there, right? So we got a little bit of an issue. We've got the UVs all sort of laying on top of each other, right? So that's the first thing we're going to have to do is redistribute our UV shells so that they occupy their own space in that 0 to 1 UV coordinate context, right? So I'm going to come over here, and this should work. Just a simple UV layout. Let's see. Oh, we got non-manifold geometry. I don't want to deal with non-manifold. Oh yeah, there we go. Okay. So the procedural operation has laid out these UVs for me so that they're occupying their own space, right? Now let's take a look visually at what we're dealing with, right? That's cool. Another new addition to Maya. So you can see what it's done. It's automatically tried to figure out what size those shells are supposed to be in relationship to the size they are in the scene, which is basically what I was going to show you guys, right? So if I come over here and I grab these here and I go to the UV shell, if I move this over, this should be our large cylinder, which it is, right? So again, you can see that the UV shells are trying to occupy the space in the UV coordinate grid that is equal to what their size is in the scene. So this is what we kind of need it to be when we're doing any kind of complex UV unwrapping operation, right? Okay, so that was easier to show than I thought it was going to be. And let's see what else. Okay, any questions so far about that? Okay, so let's say we have a situation. Oh yeah, no, yeah, that's the one thing I want to touch on as well, right? Now, we have the ability to texture these objects individually, right? Or we can do what I've just done here, as combine a variety of objects onto one texture page. This is a technique known as texture atlasing, right? So this is used occasionally. I don't know how widespread it is in use, but It's used in a way of optimizing a texture load, right? So let's say, for example, you've got a level. Last time I used this was on Hellboy, right? So when we're building the Hellboy level, right, we've got all these objects. Let's say we're in the what is it called? It was an enchanted forest. It was a haunted forest with a graveyard. Can't remember the name of the level. And headstones and all this kind of stuff, right? So we got the headstones, we got the gnarly trees, and we got the ramshackle kind of New Orleans style cottage, right? Sitting in the middle of this swamp, right? Now there's the option to be able to create a texture page for each of those. Problem with that though is you got to load an object, load the texture page, load an object, load the texture page, load an object, load the texture page, right? So the technique of texture atlasing is this idea is that we can take an entire level to a certain degree, combine all those objects, and have one texture page assigned to it. So then you load object, load object, load object, load one texture, and then draw, right? So this was a technique that found a certain degree of efficiency in terms of being able to load levels a little bit quicker, right? So texture atlasing, again, it's just one page. Now, here's the tricky part of creating a texture atlas. What resolution do you make it, right? Because if you got a massive level that would require an 8K texture to texture everything on that level to a good resolution, you might be defeating the purpose, because you might have one big texture page that takes just as long to load as a whole series of smaller texture pages, right? So it's, again, as with everything in game development, it's a balancing act in terms of what you want to load at what time. So that's texture atlasing, and that's texel ratios. So I've bombarded you with a lot of stuff at the moment in this short period of time. Do you guys have any questions at all about that? Nope.
No, I think I'm pretty happy with what's been said.
Okay. So we also have the ability to use UV sets and assign object to different UV coordinates, right? So the way this works is when we introduce material properties, things become a little bit different. So let me take this object, right, move it off to the side, and then I'll come in here and I'll create another, let's say, sphere, create another cylinder, right, something like that, right? So let's say we've got a couple of additional props in our scene, right? And, you know, let's say I want to assign a new material. So for this material definition, maybe we'll use a blend, right? And then I'll come over here and I'll assign a blend to this as well. Let's change it up, make it a Phong, right? So the difference between, you guys know the difference between the material properties of Lambert, blend, and Phong? Yeah? Okay, cool. So I'm gonna pop over into my blend material and maybe, you know, crank up the specularity a little bit. It's nice and bright, right? That was pretty bright, right? Okay, so now we have a situation where we have our, let's say, our level map with our texture atlas. We got a couple of black areas. I'm not going to investigate that at the moment, but the black areas indicate that there are issues with the normals, the vertex normals and the face normals. And it's usually solved by, let's see if I can do it super quick. I'm just going to come over here and go to my mesh display and let's reverse those normals. Oh yeah, of course, it's going to reverse on the whole object, right? So what I'd go do is I'd separate that object out, reverse all the normals on it, and then everything's fine, right? But we'll leave that for the time being. So we've got this one, say, texture atlas dealing with multiple objects here. And then we're loading in another material with its own texture and another one, right? So that's a material calculation for each of these sets of objects. Now, let's say we change our mind and we go, you know what? I want this to be like the same as my cylinder. So let's say I change my mind and say, you know, I don't want to use a Phong. Phong's a little bit older tech. Let's go with blend. James Blend came along and wrote a better sort of shader than Bui Tuang Fong, so let's use his. Right? Now this is a little bit of a waste, right? So we've got one object being loaded and a texture being calculated for that, and material properties being calculated for that. Same with this other object. The vertex transforms being calculated, texture being loaded, material properties being calculated, right? But the material properties are the same. I was like, okay, well, why can't we just calculate the material once, right? So how about we join these two guys together and make a texture atlas? Fine, that worked for us before. But then the art director comes along and says, no, no, no. I have specific texture sets for each of these. They're at different resolutions, and it's really important we maintain that. Okay, so how do we assign a singular material to these objects, but have different texture maps for them, right? So I'm just backing up because it's very, very similar in context to what we did with the texture atlas. The key difference being that we combined the objects on this particular situation with this material definition, but kept it in the 0 to 1 UV page. What we want to do here is the same thing, right? So we're going to come into our object here, and we're going to do another mesh combine, right? So now they're one object, but we're going to come in here and let's grab those UV shells. Oh, it's probably easier to just grab this, actually. And then we're going to move the sphere's UV shell to a different coordinate location on the texture page. Now, what we can do, and a lot of texture sort of painting applications like Substance Painter and Mari and that kind of thing support this methodology, right? So we've got effectively a single combined object, a single material definition, but unlike this texture atlasing where we got a single texture, we want two separate textures on this object. And I'll talk a little bit about the context of where you would use this, right? So I'm going to grab this object. We've said for the cylinder, we're going to use the 0 to 1 texture space, or the 1001 UDIM, as it's oftentimes referred to, right? For that cylinder, that's fine. Normal, we get it. But I did tell you that from sort of beyond the 0 to 1 texture space, it's tiled ad infinitum going off into space. So how can we do this? How can we take the UVs of the sphere, shift them over, and have them occupy this space and not be textured with the same texture? Well, what we would generally tend to do is create a UV set out of this, and we create what's called a layered texture, right? And so what the layered texture will do, I'm not going to build it for you because you don't want to sit here and watch me do it, but I'll explain the concept for you. So what a layered texture does is that it allows you to load two textures, but inside the node, you can say, you know what? Beam the first texture to these coordinates, beam the second texture to those coordinates. That's it, essentially, right? So you can actually tell the layered shader node where your object projection needs to hit in the 0 to 1 UV space, right? Now, here's the interesting thing, right? For the texture reference to 1001, it's still tiling ad infinitum all over the place, right? But for this set of UV coordinates in this UV set assigned to this UV grid, it's going to be a specific texture that we assign to that. That'll be beamed all over the texture page, right? So this way, we can control what vertex set gets assigned what texture page, or texture space, rather. Right? Okay, does that make sense? Yeah, okay, cool. So what I'm going to do is I'm going to load up a texture and walk you through, load up a character model, rather, and walk you through how I would approach UV unwrapping that particular character. So let's see in here. I got a couple of default humans in here that might be worth taking a look at. Okay, yeah, I think I'll do this because this is a plane that I need to UV anyway. And we'll take a look at this. Might be better actually than a character, I think. Okay. So here we've got a plane model. And I do indeed need to UV unwrap this guy because I need to use it a little bit later on. Now, one of the things that a lot of 3D packages will do is they'll have a procedural operation up here in the UV menu that'll allow you to automatically unmap, right? So you guys might find this useful if you have to open up Maya or whatever to generate some quick UVs. So what you can do is you can define the dominant planes that you will be projecting onto your object. So I've chosen 6 planes, which will just create sort of an invisible cube around my object and project from those directions, right? You can increase the number of planes that you're using to project into your 3D space, right? Or you can choose to optimize, you can stay at 6. You can choose to optimize for less distortion or for fewer pieces. I always opt for fewer pieces because the idea of getting this UV texture page sorted for you is to have as few pieces as possible to help you organize and move things around. Case in point, right? If I needed to find the right axle of one of the landing gears of the plane, where is it? I don't know, right? One of the disadvantages of automatic unwrapping is that the procedural operation may just grab a bunch of polys and just stick them somewhere on your UV page and you have no idea what the reference is to the object, right? So I generally tend to select fewer pieces because you get shapes that you can kind of recognize. Like that looks like a wing, that looks like the main fuselage, right? And then you have the option to be able to load the projection in to your node graph so you can adjust the projection coordinates and things like that afterwards. But here I'm laying it out into the square, right? You can choose to overlap your UVs, but nobody really does that. And you can choose to tile it as well, right? But I generally tend to do an automatic unwrap into the square, right? And then you can choose what size your texture map will be, right? Now, one of the things that we generally tend to do, I don't know if the automatic unwrapping does this, is we generally try to leave something like a 4 to 6 pixel space between the shells and between the UV map and the edge. And this will allow for MIP mapping operations to occur. What ends up happening with a MIP map is that the pixels become chunkier and bigger as the MIP maps get smaller. And so you'll have the texture color kind of bleed outside your shell a little bit. Just something to kind of be aware of. And then I'll create project. Now this gives me the option to create a new UV set, which will say, okay, now you've got a UV set assigned to these UVs. You can move them to any square as long as you project the texture into that square. But I'm going to leave it for now at the 0 to 1 UV space, right? And then I'm not going to hit project because that's basically what I did here. And so you can see that the procedural operation gets a few things right, gets a few things not so right. So we're going to have to go back and kind of manually tackle this, right? Now, one of the things that I generally tend to do when sort of approaching this sort of project is to make sure, especially if I want to combine these objects into a single contiguous piece, I might first separate them as I've done here, right? So I've actually separated the geometry so that the more complex objects are invisible and I've got the simpler shapes to deal with. So I've hidden the more complex objects so that we can have an easier discussion about how we would approach this particular piece of geometry, right? Okay, and that's not a plane, that's just the grid. So I'm gonna reset my grid here a little bit because it's pretty crazy. I'm gonna say grid lines every 100. That's a bit better. Okay, I'm just gonna take 2 minutes for a comfort break. I'm gonna refill my cup of coffee. I'll come back in and we'll dive into sort of UV unwrapping this plane. Okay, so we'll take a couple minutes. I'll be back. All right. Cheers. Hey guys, I'm back. Put this broadcast back on. Okay, there was one other thing that I wanted to show you guys. Oh, I closed that scene. Because one of the things I wanted to do is also walk you guys through exporting this out and setting up the material inside of Unreal. But we'll do it with this plane. We'll take it from there. So that is still streaming. Flux capacitor fluxing. Okay, so here's where a little bit of sort of strategy comes into play, right? So one of the things I might do is sort of separate the shells on this. I'm just thinking now. We've got some really, really good seam lines already to work with. So I'm going to right click. I'm going to select a bunch of faces. Yeah, again, I'm not going to give a proper UVing lecture anyway. Just trying to think of a good strategy. Okay, so let's grow this selection out just a little bit. And I'm going to come over into my UV editor. I've selected most of the polys for that wing, and I'm going to hit Control F12, convert that to UVs. And I'm going to move this to see how, I think I got the whole shell. I didn't. That's okay. I can just go to UV shell. That'll guarantee I've got the whole shell. And I'm just going to move this off to the side. Right? So I'm going to deal with this guy a little bit later. You can see we've got bits and pieces of UV shell floating all over the place. Again, one of the disadvantages of any kind of procedural unwrapping. Oh, I'm going to do the same thing with this guy here. Select those. Oh, actually, let's go into face selection. I'm going to grab those and we'll grow it out a bit. Let's see if have I grabbed. Oh, I've grabbed all of them. That's good. I can move all these polys maybe down here for the time being. And this allows me to sort of custom select these guys when I need to. I'm just choking up the shells a little bit here. So I can come in and grab one side of the wing just in the UV editor and hide it. And we'll grab the other side, hide that guy. And I'm just checking to make sure my selection is intact. Okay, that's cool. I'm just gonna take a couple of seconds here just to separate out these other wing pieces, and then we'll take it from there. So I think that, nope, one more. Nope, back this up. I'm gonna have to do this way. 12 it. And F, and I'm just making sure that I've selected all the pieces that I want for that, and I'm going to go to the UV shell, and I'm going to move this guy out of the way over here as well. And it's a good way of double checking my selection if I can just grab these guys and Control H, hide it. That's cool. And I'll come in here. Same thing here. Okay, so I'm just going to tackle the one side. So we can see that there are already a number of issues with this piece of geometry and with what automatic unwrapping has done for us. Number one, we've got sort of, oops, somewhere along the line here. Oh, there it is. Grab this. Just want to grab this fuselage. Nope. Okay. So in this particular context, I'm actually just using the UV sort of quadrants as just a workspace, just a way to organize myself, right? Nothing fancy at the moment. All right, let's grab these guys, grab those faces, and then control hide, and we should be good to go. And then I'll grab those pieces and then control hide them. All right, so we got the fuselage, right? So this is fairly straightforward. It's just going to be a cylindrical unwrap to a certain degree, but I want a little bit of control over the UV distortion, right? So what I'm going to do is I'm going to grab these faces here and we'll apply just a bog standard cylindrical unwrapping to this, right? So I'm going to come over here and I'm telling Maya to do that cylindrical projection, but I'm going into the option box to make sure that insert projection before the deformers is set up. So it's here, and this way I can look at the projection gizmo, and straight away I can see that the rotation angle for that cylindrical projection is incorrect, right? So we're going to want to rotate this guy 90 degrees to the X, and that gets us the correct orientation for that projection. And let's just manually scale this up. So again, I'm looking for that Texel ratio distribution, and you basically eyeball it, trying to get like the perfect squares thing going on. Now, when I come over here, that projection is trying to take up the 0 to 1 UV space. So I'm going to move it over to the right. So generally the way I work, the left-hand side will be where I stash additional UV shells, and then the right-hand side is where I sort of do my careful unwrap work. I'm just going to unwrap this one piece, and then we'll leave it at that. Now, we've got sort of texture distortion. Obviously, the central fuselage of the plane will be easy. It's more like a cylinder. It'll be fine. But we've got a little bit of distortion happening here, right? So how do we solve that? There's only a certain amount of planar projections that you have on the go that will allow you to sort of deal with this, right? And I'm using this sort of section as a metaphor for, you know, like a character's arm or something like that. So there's one other technique that I'm going to talk to you about. We talked about a few different techniques here in this lightning fast round of what UV texturing is. But there's a technique called pelting that will help us to unwrap slightly more complex objects. So back quite a few years ago, I think it was actually in the 90s, there was a shader developer, and I got to look her up because I keep forgetting her name. And I do want to, I use her as an example all the time. And it'd be nice to actually put a name to the person who created this. But there was a shader artist who developed this idea of, okay, well, if everything ends up as a 2D planar projection, why don't I take the geometry, make a cut in the geometry, apply a cloth simulation to it, literally unfurling it, right? Like an animal pelt. When the animal pelt is laid flat, you can planar project directly down on top of it. You've got it, right? And then, you know, you save a morph target and then you morph it back to its original shape. And there you've got perfect one-to-one mapping, right? So that technique is referred to as pelt mapping, right? So what pelt mapping does is it allows the vertices to find an average distance between, or sorry, the UVs to find an average distance between themselves. And so there are a number of different operations inside of Maya that use this philosophy to help you get better distribution of your UVs, right? So I'm going to come in here. The first one I'm going to access will be the unfold operation. This shouldn't do anything. Yeah, that's not going to do anything more than what's already there. Oh, sorry. There you go. Actually, let me back this up. I thought it was going to detect. It's because it's using Unfold 3D as opposed to the. I thought it was going to detect that it was already unfolded, so it was just going to make marginal changes to it. Okay, so the Unfold 3D is basically at the heart of this procedural pelting technique, right? So you can see what happened here. I'm setting it to have a map size of 1K, right? And so when I apply this, right, that's basically what it did. It took the cut lines of where I cut the UV shell and just sort of procedurally unfurled it as if it were cloth. Let's take a look at the tail end. You can see at the tail end of the fuselage, we've got a better distribution of the squares, right? Now, there are other issues as well, right? So the squares are starting to go a bit rectangular, and that's because if we look at the shape of the tail end of this, it's sort of on a wonk, right? Well, it's a general rule of thumb that when you do any kind of UV unwrapping, is to try to maintain the orientation of the object in the viewport on the texture page. Now, we're going to have some sort of diamond shapes here because of the way that that shell fans out. But that's, you know, something that we generally tend to work with. I generally tend to try to lay out the UVs so they match the orientation of the object. So I'll basically, even though this has a pelting operation, as I unwrap each part of the fuselage, I'll lay them out here so it looks like a fuselage, right? This gives us what's called human readable texture maps, something that every texture artist on the planet will love you for, because they can just open up the texture page and they know exactly what the object is because it still looks like the object, right? As opposed to a completely procedural unwrap operation where you're just like, what is that? Is that one of the, what is that? Right? So being able to have these human readable shells is sort of really important later on down the pipeline. But anyway, that is at the heart of pelt mapping, right? Nothing really too fancy in terms of what's going on there. Okay, so there are a bunch of different techniques that are available in terms of getting those UV shells laid out, right? Okay, so any questions about that at all? Everyone clear about UV unwrapping and all that? Yeah, okay. Yeah, it's pretty straightforward. I'm internally in my head as I was talking to you guys, I'm gonna save multi-texturing till later, just because there's a few interesting things that you can do, and I'd like to bring in an older prop that I did a long time ago that effectively demonstrates multi-texturing and the advantages of it. But let me dig that up. I'll go dig that up for next week. Okay, so let me actually open up a blank project as opposed to coming in here. Oh yeah, sorry. That's so I wanted to actually describe to you the relationship of the projection with a texture, finally, right? So a lot of this stuff that I've talked to you guys about is in terms of what are the ways we can unwrap UVs, how do they work, but it's all in context with the grid work, right? So the last technique I wanted to show you, we'll bring a texture in, we'll use all the concepts I talked about, but in a slightly more interesting way, right? So I'm going to grab this sort of set piece, and this is from some freelance work that I've done. And what the team needs is they need a 3D representation of this building facade, right? So I'll just show you the process that I generally tend to go through when approaching something like this, right? So one of the things that I need to do straight off the bat, if I want to use this texture and create a complex prop from it, I need to do a few things to it, right? And this all has to do with how the texture coordinate workflow limits us in terms of the kind of data that we can use, right? So let me go to where this is. Is there? No, there's no quick find. Where are you? Where are you? Where are you? If I go down. I should be, there it is. Okay. All right. So I'm going to right click and open this in Photoshop. Open with. There you go. Just wait for this guy to open up. And again, I'm not going to do this whole prop. Unfortunately, I have to do this part of the process because I kind of need it. But I'm not going to, again, do the whole prop. I'll just do enough so that you guys get the idea and move on from there. Now, what I need to do with this is I'm going to use this as a planar projection inside of Maya to help me recreate this prop. Now, to do that, I need to make sure that this is completely orthographic. We've got a number of different issues here, right? Number one, we've got lens distortion, right? Which gives us, well, sometimes called barrel distortion, which gives us a slightly circular shape or spherical shape rather to this image. And it's also off kilter, right? So I'm just going to come in here. I'll just do sort of a rough job with this. I'm just going to Control J, duplicate that layer. And I'm just going to sort of see if I can match up the top. And then with that, I'm going to, let's see, let's just use warp. Let's see if that works. I'm going to try and warp this guy out. Oops. Just to try and get rid of that bell shape, right? Squeeze it in and just sort of work this texture out. Now, I have to be careful at this point because I don't want to distort the geometric proportions of that shape because it has to be physically accurate. But I have what's called a LiDAR scan that will help me to kind of double check my work when I'm done. For those of you who don't know what a LiDAR scan is, it's basically a photographic scan of the area and reconstruction. So I'll be able to sort of gauge my work based on that. So I'm checking the middle here, that looks good, and then I'm checking the ground plane. The ground plane's always dodgy because, you know, the ground terrain tends to shift over time, so you won't get too accurate a result. And then I'm just going to check my door frame. They're looking pretty good. And then I'm just going to save this guy off as a texture. I'm going to apply those transforms. Did I click don't apply? I think I did. Oh, no, I didn't. Oh, yeah, of course. There you go. All right. So I'm going to save this on my computer. Now, I want to preserve the texture data as much as possible. So I'm going to save this as T for texture, and this is the derelict hospital. This is the front entrance, and call it 1. And I'm going to save this off as a TIFF because the TIFF will save 16 bits per channel. I don't need to save it as an EXR. I'll remove the layers. We'll save this. So it'll flatten it for me, and there we go. Oh, I forgot to select 16 bits per channel. That's okay. Okay, so we've got that image, and I'm going to save off the plane because I'm going to come back to it and do some further work on that. And then we'll create a one quick sec while I set the project and save this guy off. Let's go here. Yeah, let's go in here. Oh, yeah. Okay, so I'm going to create a new scene here, and I am going to create a polygon primitive plane. Now, what I want to do is I want to make sure that that plane fits the aspect ratio of the image that I'm currently working on. So I'm not going to talk in terms of scale just yet. I'm just going to come over back to where I have my content textures. I'm going to take a look at this guy. I'm going to take a look at the properties on it. And again, with scale, I'll deal with that in a sec. So we got 3840 by 5760, right? So I've moved that off to the side. I'm going to come in here. I'm going to create a polygon primitive plane. And I'm going to zoom in on it. Now, the first thing I'm going to do is I'm going to go to the parametric controls. And I'm going to set my subdivisions super low. And I'm going to, because I'm fairly lazy, I'm just going to come in here and put in, I don't know, 38.4. Oops. Writing into the wrong window. There you go. So 38.4, right? And then we'll do 57.6. Which is not necessarily the aspect ratio that I want. Sorry, not necessarily the size that I want, but it's giving me the aspect ratio that I want, right? So I'm going to pop in here, and I'm just going to make sure that the rotation is 90, and there we go. So a couple of things I'm going to do. I'm going to adjust the pivot down to about there, and then we're going to snap this at world 0, 0, 0. So we don't have to deal with any kind of negative values in the negative quadrants, right? Edit, delete by type. I'm going to get rid of the history, and then I'm going to freeze the transformation data. So it's at world 0, 0, 0. Okay, so now I know I've got a piece that has got the same ratio as my texture image. So I'm going to right click on this guy. Actually, let's name this first of all. Geo. All right, so with that in place, I'm going to right click and I'm going to assign a new material. And for this, I'm going to chuck a blend on there, even though there's no real specular property on that building facade. I just like having a specular channel available to me. I'll just turn it off. Right. So in here, I'm going to call this M for material, hospital 1. Now I'm going to assign a texture to this material that I can assign to this object. Inside of Maya, by the way, as well, we have the ability to create these complex surface shaders by creating groups of surface material, right? So if I ever wanted to, I can come back here and expand the surface material by adding a volume material and a displacement material. But we're just working with a base material. So I'm going to go into the color channel or the albedo channel, and I'm going to click here, and I'm going to create a node that I'm going to attach to this. And this node is going to reference a texture on the hard drive, right? So I'm going to come over here, I'm going to grab my file node, and I'm going to apply this as a projection, right? So what I generally tend to get straight off the bat is this projection grid, very similar to the UV grid that I talked about, this texture support, right? So I've got this projection. Now it's defaulted to its own sort of size. What I want to do is I want it to fit to the bounding box of my plane, which it does, right? And then I'm just going to physically grab this and move it out of the way. I don't really need it in the front there, right? So with that in place, I'm going to select my object. My object is there with the transform data, the shape node, and my texture projection. And I'm going to go to where I've got that projection data, and I'm going to go to my file node, and I'm going to navigate to where I drop that image. And that texture, there we go. So now I've got, oh, it's taking a little bit to load, is it? It's not that big. Okay. Okay, so that texture is now plugged in. So this might actually kind of help you visualize how sort of projections work behind the scenes. Now, what I want to do is I want to see this texture on my object. Oh, actually, it's not showing me a sample, so I'm wondering if I need a different file format. But let's give it a go. So I'm going to come over here to my shading menu, and I'm going to turn on the hardware texturing, right? Oh, there we go. So that's fine. So now we have this situation where, let me pop over into my node editor. This guy up and show my input output connections. So now we've got the geometry plugged into our shading group. And if I show what's inside the shading group, this will show that, and this is the process of operations that are kind of happening in the background, right? So here we've got our place 2D texture node controlling the projection coordinates of our texture. We've got the place 3D projection node that's giving us the 3D coordinates of our plane, all feeding into a central projection node that's pumped through our material definition into our shader group and onto our object, right? Don't worry about that. That's another operation later on down the line, but this is plugged into our geometry. So that's kind of what's happening. Now, effectively, what is going on visually is that we have literally put a camera projector in front of our geometry, right? So, whoops. I'm going to come in here and I'm going to go into my edge mode. And I'm going to start pulling some shapes out here. And partially just to show you guys kind of what's involved with this. So I'm going to come into my insert edge loop tool. And I'm going to come in here and I'm going to insert an edge loop. Now I'm going to find just that kind of ledge edge. Now you can see one of the problems with trying to recreate real world environments is that, especially with a planar projection, you have certain areas of the object that you cannot recreate, right? Actually, let's see if we can, yeah, let's just do that. So I'm going to come in here and, yeah. I'm not going to recreate the gable. I'm just going to come in here and select, whoops, along here, make sure our edges line up. And I'm going to select this. Actually, let's cut the ground plane as well. And I will find the base of that object there. And actually, that is all I need. So I might grab those guys and just delete those. Grab that face. Now what I'm going to do is I'm going to come in here and do a polygon operation called an extrusion. And for this extrusion, I'm just going to push this back, right? A little bit away from the sort of the gabled roof. Right? Now, let's talk about a couple of things that are happening here. So first of all, I'm going to, as I generally tend to do, keep a render preview window open just to see how my projection is working with the geometry. Okay, and I'm going to choose a slightly different renderer. Let's escape out of that, and I'm going to come in here and choose my software render, and I'm going to set the test resolution to 1/4. And let's take a quick little render. So you can see inside this real quick test render that we've got some shadowing here, right? So I'm really sort of focused on trying to build out this object a little bit. Now, I'm going to delete some of the extraneous surfaces. Oops. And then that way we can make a couple of observations, right? Now, this is one of the techniques I generally utilize quite often when I have to really quickly build photorealistic sets. Now, there's a couple of issues here. Number one, we don't know how far in we need to extrude that back wall, i.e. we don't know how far that gable overhangs because we don't have that information in the image. And number two, you can see visibly what happens with that texture stretching that I tried to show you with the grid work and the pattern, right? That's essentially what's happening. You've got color detail that's a pixel wide being forced to inform that surface detail that's obviously a lot bigger than a single pixel width, right? But that's what the projection is doing, is it's just shooting that image flat out into space, right? Now, the reason why I wanted to show you this is it's kind of the opposite of UV unwrapping. So in terms of UV or unwrapping or gaining texture coordinates, it's kind of like pre-unwrapping your geometry to get it ready for the projection. In this particular technique, nothing new here, same underlying technology. What I'm doing is I'm saying, look, just project onto the geometry straight away, right? And don't alter based on UV coordinates. I'm just going to cut in what I need. Now I'll explain to you how that works by going a little bit further in terms of, so if I come in here and let's go to my insert edge loop tool. So I'm going to, let's say, cut areas for the windows, right? Now let's say I've missed that object there. And let me bring back a cube for comparison, just to show you guys. So I'm going to come in here and create that polygon primitive cube, and we'll scale it up, right? Bring this guy over. And I'm going to open up the UV texture editor again, just so we can see the checkerboard pattern. And go to UV editor. And I'm going to try to replicate the same sort of situation here. So let's pop that in there, and there, and there, and there. Okay, so let's say we have a situation where I need this edge to be a little bit further out, right? It's like, oh man, you know, I didn't make this window wide enough, or it's too wide and I need to bring it in. So I might grab that edge and I might move it closer. Now you see what happens, right? We get texture distortion because these vertices are referencing the UV texture coordinates here on the object, right? So as I'm moving the edge, my in the background is going, okay, well, I know these vertices correspond to those areas on the texture. Therefore, when I render this guy out, I know that that wherever those vertices are located, I will texture it based on this UV map. Right? So if we wanted to move that edge over, we'd actually have to come in and redefine our textural coordinates in here as well, right? And say, okay, well, look, redistribute that texture information on that object. With this particular methodology, which you can also do in OpenGL, by the way. I don't know how, but I've seen it being done, right? In the past when working with projected props, right? So with a pure projection, this is with no UV coordinates at all, or no texture coordinate. It's just being sort of beamed into space there. Oh, why did I? Oh, that's because I got the UV texture. So what I can do here instead is I'm going to grab that edge and I'm going to move it. See that? The texture is not distorting at all, right? Because it's continuously being planar projected into the shot or into the scene. So I can quickly make the adjustments that I need, knowing that I won't distort the texture space. But I still have the same problem with dealing with planar projections, in that the minute I want to model any kind of geometry detail, this is what I get, texture stretching, right? So how do we mitigate that? Well, I'll show you. Let's let's move over to this, right? Now I know that it's a planar projection affecting the object, right? So I can really simply come in here, put my edges, put my edges there and there. And if I say want to extrude it inward, I can look a little bit and say, you know what, I got a bit more texture detail in here. And then maybe on this side, let's grab this edge. I'm going to move that edge over a little bit, and I'll go back to my insert edge loop tool, and I might add just a little bit in there. It's a little bit off. This guy over just a little bit. It's not much, but if I come in here, I'm going to insert another edge loop here. What I'm trying to do is kind of custom define what I want to stretch where. A little bit inside the image, right? And because I don't use an extrusion, I can just grab that face and then just push it in, right? And you can see there's distortion, obviously. And if you go too far, you get stretching again. But there's a little bit more surface detail to sort of inform what that inner edge looks like. And you can see you can only go so far with it before the illusion starts to fall apart. But it looks much better than, say, this solution, right? So if I come over, oops, don't want to do that. Oh, I did a double extrusion. That's those guys there and there. And then move this guy back, right? So again, we've got a zero length edge here. Not zero length edge, but we have two vertices that are sitting mathematically on top of each other, and therefore we get stretching. These vertices have been offset slightly, so we get a little bit of a textured look, right? So those are the challenges in terms of dealing with texture coordinates and 3D objects, and the various different techniques that are available to us in terms of being able to sort of create complex objects, whether it's photoreal or whether we're dealing with basic geometry. So there's a lot of different techniques that I talked about. There's the pure projection technique, there's the texture atlasing technique, etc., etc. And I think that that is all of the techniques that are available to you in terms of how to approach sort of complex pieces of geometry and getting great looking materials and great looking layered textures on your objects. Okay, any questions, thoughts, or comments about that? No? Okay. All right. So here we are in Unreal, and I just wanted to really briefly, before I flip over into a new project, show you that one of the sort of viewport tools that are available for you inside of Unreal, I believe under the Lit menu, is, where are we now? Visualizers, not the LODs. Where are we? Light map density, shader complexity, quad overdraw, mesh. Oh, there we go. Mesh, I think it's this one, mesh UV density. No, it's not that. Oh, I see. Gotta select the UV channel. Let's try. Oh, it's a diagnostic mode. There was a way of previewing your scene. I'm just looking for it at the moment. That will show your texel density in your various objects. Not a huge important detail, just something I wanted to show you guys, but I can't remember where it is at the moment. So is it the material texture scales, required texture resolution, visualizer ratio between the currently streamed texture. Nope. No, that's not it. Okay, so I'm just going to flip back over to a new project. So let's go to new project. game template, blank one. Oh, actually, I've got a lecture project. Let's open that instead. Let's see. Mhm. Sorry, guys. Unreal has a weirdly long load time. Just sort of hit me in the last week or so. I might have to take a look at my USB hard drive, which is what it's trying to access, and see if there's something dodgy going on there. Okay, well, whilst it's loading up, did you guys find that sort of a little bit easier to kind of wrap your head around in terms of how UV coordinates work, especially in terms of an artist-centric or texture artist workflow? Is it all stuff you guys already knew? Which is always a danger.
No, I wouldn't say it's stuff that I knew.
Okay. One of the things that I'm hope is beneficial is just being able to visualize the tools, because the tools are basically, and I'm hyper simplifying this, they're basically a visual UI placed over top of the operations that you guys need to consider, if you know what I mean. Like the underlying procedure that's happening is identical to the stuff that you're dealing with. I didn't talk about how the data is converted into, you know, clip space and screen space and etc. But basically the procedures underneath are governed by what you guys are doing. This is just a UI wrapper around the idea of generating texture coordinates. And again, I'm hyper simplifying it, but hopefully it'll give you an idea. And again, you can problem solve. If you start bringing in complex pieces of geometry and you're struggling with making it look right, this will give you some ideas in terms of things that you need to look for, or things that you might be able to do to make your sort of visual prototype stand out a little bit stronger. Okay, so we've got UE4 initializing. I think the biggest balancing act for me is just texture resolution. You know, coming from sort of an art pipeline background, I'm always gunning for the largest possible texture resolution I can get, right? And then balancing that with the various different objects inside the level. Okay. So let's go into, that's the third person. Let's pop into this one. Conspicuously absent from a lot of the stuff I talk about are tileable textures. And this is more kind of a legacy thing for me. It's just that when I first started in the games industry, everything was tiled just for the sake of efficiency and just the graphics pipeline we were working with at the time. And since then, I avoid tiling textures as much as possible. And I love, as much as possible, custom texturing every single object. It's sort of the artist's way of doing things. I've started since adopting using tiling textures for things like ancillary effects like rust and dust and things like that, right? Okay, so let's get out of this for a second. I'm going to pop back into one of the demo maps. Okay, so let's talk about what we want to do in terms of texturing some of these cubes, right? And I'll just do one at the moment, right? So let's take a look at this guy, right? So inside of Unreal, I've selected the geometry object that was initially created inside the package, right? So one of the sort of disadvantages of dealing with geometry that you create inside of Unreal is that it doesn't exist anywhere else, and you can't work on it in any other package. So if I take a look at this cube, I'm just going to name it for now, so I know what I'm dealing with. So this will be wall piece. I'll keep the same cube numbering just so I know which cube it was initially. And if I right click on this, I can very easily convert this to a static mesh. So what that does is it takes this procedurally generated object inside of Unreal and creates something tangible that I can use somewhere else, right? So I'm just going to pop this in. It's going to automatically create a meshes folder for me. And I'll probably use Unreal's naming convention, SM for static mesh, and we'll call it wall 7, right? So now I've converted that, and I've got that in my meshes context. And the unfortunate thing is I'm now going to have to then move this guy over here to get it in there. Oh, right. It didn't bake in the transforms. I thought there was an ability to bake the transforms in one of these menus. Okay, so what happened there is that this came into the Unreal Engine environment as a cube, right? And the transforms were applied locally within the context of the level that we're currently running. So when I converted it to a static mesh, it did so. It converted it based on the base transform data of the original object, not the inherited transforms that we gave it inside the level. That's okay. I will go back and create another wall later as a static mesh. I wanted to bring it into sort of Maya to just show you how it is initially UV'd. It's initially UV'd like the cardboard box layout, right? So there's nothing fancy going on there. Okay, so let's go in here and let's apply a material. First of all, I'll open up the static mesh editor by double clicking on this geometry here. And you can see it's showing me the original object without the transform data on it. Again, another disadvantage of working with the native geometry inside of Unreal. This is why I prefer to create my geometry in packages like Maya or Blender or something like that and bring that in contextually later, right? So there is our geometry, and we have a material slot. So inside the material slot, which is the same as the material slot over here, right? We can custom assign what we want in terms of what material will be affecting this particular object, right? So in here, it's defaulted to the world grid material. What I want to do is I want to create a new material, right? So inside here, I'm going to right click and create a new folder for materials. And in here, I'll give it an M underscore wall 7. And that will be my specific material for that object, right? Now, I can double click on this and we get into our material editor. Now, it's got that default grid texture that Unreal does. Yeah, it's just updated to just the black because now it's referencing this new material, which has nothing plugged into it. And what we're into now is our material editor. So our material editor looks very much like all of the other editors inside of Unreal, right? In that we've got a preview viewport window, and we've got a details panel and a number of operations across the top that are specific to the context of the editor we're working with. So here we've got our material editor, and we're inside the node-based connection here. And you can see that I've got base color, metallic, specular, roughness, and emissive color, right? So Unreal Engine defaults to, and I say default, but I think that there's no legacy support for this anyway. But we are using the PBR workflow in terms of attaching textures to this object, right? Now, inside the material editor, we see a number of different default objects that we can use. I generally like to take a look at a preview object that's similar in context to the geometry, or you can actually set the preview mesh based on the geometry you have selected in your content browser, right? So if you really, really, really want to sort of be able to build your material with the actual object that you're working with, you can select it and then grab it here, right? So what the material editor is saying is, look, that's the actual object you're working with. But for the sake of just sort of efficiency, I always try to select a simpler object until I get the texture working to a certain degree, right? Now let's go in and grab a I don't know. Let's just grab a real simple brick wall texture, right? So I'm gonna pop in here and just look for let's do stone wall. I get better results when I just type in stone wall. Okay, so I'm going to open this image in a new tab. Yeah, because it's giving me the preview. Preview image is fine. So I'm going to save this image now. And let's just pop that. You know what? I'm just going to pop this on the desktop for the time being. T_. Yeah, Stonewall. I'm going to save that. Now, there's a few things I can do here. I can first bring my texture into my Unreal Engine project and then drag and drop it into my material editor, or I can just drag and drop it from the directory location into my material editor. But I like to keep things together. So I'm going to pop into my materials folder and I'm going to create a new folder for textures, just so that my textures are there with my materials. And I'm going to pop this guy open, and then I'm going to go to where I downloaded that texture, and I'm going to bring that in. So texture was downloaded here. Are you taking off, kiddo?
Yeah.
Okay. Where are you guys going?
Yeah, I'll spell myself.
Oh, nice. Nice. Cool. You okay?
I wonder if I could take your AirPods with me.
Oh, yeah, for sure. Yeah, go grab them. They're in my room. I think I moved them in my room. Failed to import. Oh, unknown. Okay, one sec. Let's see if I'm going to try to force the extension to a JPEG. No, it doesn't like that. All right, let's see if I can. Let's grab another one. Oh, I thought they were. No? Oh! I grabbed them. Here it is. I don't know if there's much charge on it, but here we go. Yeah, no worries. Okay, guys, I finally got a stone wall. So let's grab that stone wall texture, and I'm going to pull it in here. It's going to import the stone wall texture for me. And I'm going to take the material editor, I'm going to pull it off so I can have access to it, right? So I'm going to come in here, got that stone texture, just going to drag and drop it into the material editor. And so the one thing I like about the node editor is it intelligently senses the objects that you pull into it and recreates the node tree based on what you pull in, right? So now I've got a 2D texture sample node, which you can also access here, right? So if you type in texture sample, you can grab that node as well, right? And then I'm just going to take the RGBA and then plug that into the base color. And there we go, right? So there's our texture. I can save, and then I can apply it. And when we pop back over, let me stash this guy back up here. over here, now we can take this material and we can assign it. Oop. Yeah. So inside the geometry object that I have selected here, I can come down and choose the material MWall07, and there it is. Now, it's using the default UV space that came with the cube. So we've got a few different artifacts, right? We've got the squishing of the texture here, right? But you can see in terms of a planar projection, it's not too bad. Right? So that's just a real simple, straightforward, how do you create a material? How do you apply a texture? I wanted to go a little bit more in terms of putting a little bit more of a complex material together, but I guess I'm gonna have to save that for next class because we're at 5 minutes past 12. So we're gonna start building sort of complex shaders and textures inside of Unreal as well. And it's gonna be very similar in context to a lot of the stuff I talked about in the early days with Substance Designer. But it will be more Unreal centric so you guys can get a feel for it and that kind of a thing. Okay, so that's it for me. I've gone over, but any questions at all? Okay, that's cool. Again, this whole lecture was dedicated to sort of understanding the importance and the value of texture coordinates, how they fit in the pipeline, various different ways of achieving really, really good unwrapping. How important it is, especially if you're working with photographic textures and you're trying to achieve photorealism, just understanding what that is, understanding what texel ratios are as well, and then sort of pulling it all together. I think I've covered every single technique that I use on a day-to-day basis when I'm texturing and building materials for objects. If I've missed anything, I'll come back and I'll hit you guys with it next class. But we're going to move on from this now. Okay, yep. It's all good?
Yeah.
Yeah.
How much of this we'll have it recapped in the next lecture with Dave and John, because I know we're working on textures in the next lecture.
Yes, I know you are. Yeah, so I wanted to plan it this way. But they have access to my Twitch stream. So I'll just say, look, this is what I've covered. And I'll give them a quick little outline, just so that there's more of a connection. And then ideally, when they launch off in the next session, they won't have to do this preamble, so they'll drop you right into it. Right? Is that cool? Okay. So hopefully that gave you the sort of the artist perspective in terms of UVs and textures, and then I'll be lurking in your session with John and Dave, right? So I'll also pipe in if it's stuff that I've already covered. That way they don't repeat, right? Okay. With that, I'm gonna let you guys go. And we will catch up with you later. Oh, as well as the afternoon session. I will do one next week. Is that cool? I can't do it this week because I have a meeting. So next Monday, we'll log back on and I'll do an extra 1 to 3.
Okay.
Is that cool with everybody? If it's not cool with you, let me know. No problem. Again, I'm streaming these lectures, so I can always post up the YouTube or the Twitch, and then you can access that later.
Yeah, don't have anything on a Monday past this lecture, so...
Yeah, you shouldn't be scheduled for anything because, again, originally you were scheduled for 1 to 3 with me, so it should be good, I hope. Okay, cool. I will let you guys go, and I will talk to you later.
Cheers.
Yeah, cheers, guys.